Okay, in this section 3-6, the topic is graphing rational functions. And the first thing that we come to here in this section now is a set of guidelines for graphing a rational function if you had to graph it by hand and did not have some sort of a graphing utility at your disposal. So if you had to graph this thing completely by hand and you didn't have any sort of a graphing calculator or anything to use, these are the guidelines that you would use. All right, so first of all, it says let f of x be equal to n of x over d of x, where n of x and d of x are polynomials. All right, so first step, simplify if you can, and then make note of any restrictions on the domain that are in the original function but not in the simplified form. Like, for example, if you cancel the x minus 3 on the top and the bottom, then 3 would no longer be in the domain, right? Let's see. Find and plot the y-intercept by evaluating f of 0. Okay, find the zeros in the numerator by setting the numerator equal to 0 and then plotting the corresponding x-intercepts. Number 4, find the zeros of the denominator by setting the denominator equal to 0 and then sketch the corresponding vertical asymptotes, right? Because when the denominator is set equal to 0, that's how you figure out where your vertical asymptotes are. Then you can find and sketch any other asymptotes that you might have. Then plot at least one point between and one point beyond each x-intercept and vertical asymptote. So you want at least one point between all of those things so you can kind of tell the direction in which the graph is going. And then once you have all that information in, then you can just sketch the graph based on the information and the points that you get off of these guidelines. All right. Then next we have the parent function, parent rational function. Remember, a parent function is the simplest equation of each type of function, and the simplest rational function, the parent rational function, is f of x equals 1 over x. Okay, so we have it graphed here, and so here are some characteristics of that graph. The domain is from negative infinity to 0, along with 0 to positive infinity. And so the reason why that's the case is because at 0 you've got a horizontal asymptote. So 0 is not a part of the domain. Likewise for the range is from negative infinity to 0, not including 0, unioned with 0 to positive infinity, because at 0 you've got a horizontal asymptote. And so that's why 0 can't be a part of the range. All right, let's see here. So there are no intercepts in this one. Because the x and the y-axis are asymptotes, so it doesn't hit the x or the y-axis anywhere. And this particular function is decreasing on the interval from negative infinity to 0 and from 0 to positive infinity. It's an odd function with origin symmetry, and the vertical asymptote is the y-axis, as we can see. Horizontal asymptote is the x-axis. So those are just some characteristics. And so what we're going to do in the type of problems that we come to are going to be ones where we've got to answer some questions about the characteristics of the graph. So we have a rational function listed here. It's graphed over here to the right. And here are the 5 things that we have to answer about this graph. Number 1, they're asking us to find the x-intercepts. And number 2, they're asking me to find the y-intercept. So by looking, sometimes you can have more than one x-intercept, but in this case we only have one to list. And as far as y-intercepts are concerned, same thing, just one to list. Now, you can find the x-intercept by plugging in 0 for y and then solving it. You can find the y-intercept by plugging in 0 for x and then solving it. However, what I would say is, since we've got our graphing calculator with us, I would say it'd probably be easier to just graph it and then get your points for your intercepts that way. All right, so that might save you a little bit of time, so that's what I'm going to do. All right, so we've got our graph here, and so I'm going to plug this thing in, and so it's going to be y equals, 1 over x minus 3, and I'm going to come out and do plus 3. And so I'm going to push this, and then that's going to give me my x and my y-intercept of this thing. All right, so now the x-intercept is 2.667, and so more than likely you're going to see that listed as 8 over 3. as an answer choice. All right, so that's the way I'm going to write it in on my paper, 8 over 3. The y-intercept, same thing. It's also 8 over 3 because that's more exact than a repeating decimal. All right, so the next thing that we need to do is we need to find the domain. All right, so by looking at the graph, the domain would be the x values that are involved here. And really, there are two ways that you can write these intervals. Remember, you can do it with interval notation, which is what we saw here. But we have been using interval notation quite a bit over the last couple of units. And so what I really want to do this time is use set notation so that we can get familiar with that as well. So for set notation, then you're going to have this. All right, so it's going to be, the domain is going to be x is an element such that x is an element of the real numbers. All right, x is going to be an element of the real numbers, and x is not going to be equal to, the value that's excluded from my domain here is 3. All right. So like I said, we could write it in interval notation like they do on the other page if we wanted to, but I want to stress set notation also to you since we haven't used that quite as much. All right. So again, the domain is x such that x is an element of the real numbers, but x is not equal to 3. So pretty much this is set notation for saying everything but 3 counts as a part of the domain. All right, now let's look at questions 4 and 5. It says find the limit as x approaches 3 from the left and 3 from the right. All right, so question number 4 we would answer like this. Okay, we want to find, we'll use our limit notation again. We want to find the limit, okay, as the limit of f of x as x approaches 3 from the left. So to denote that it's approaching 3 from the left, you put like a little minus superscript up here by the 3. So minus is from the left-hand side, plus is approaching from the right-hand side. All right, so it's not a portion of an exponent, it's just a superscript, you would say. All right, so this says find the limit of f of x as x approaches 3 from the left. All right, so let's see what happens when it approaches 3 from the left, because then I will be able to figure out what that limit is equal to. All right, so as we approach 3 from the left, so we're getting closer to 3, right, from the left, what's happening? All right, the function itself is approaching what value? Well, it would be approaching negative infinity is the correct answer there. All right, okay, so the limit as x approaches 3 from the left is negative infinity. Now, what about the limit of f of x as x approaches 3 from the right? All right, let's see what that's going to be equal to. All right, so as I approach 3 now from the right, the limit is going to be positive infinity. All right. So the limit as the function approaches 3 from the left is negative infinity. The limit of the function as x approaches 3 from the right is positive infinity. Okay? And question number 5 now we can answer. It says find the limit as x, okay, approaches negative infinity and positive infinity. So again, we want the limit of f of x as x approaches in negative infinity. All right, so let's see what that would be equal to. So the limit as f of x, the limit of f of x as x approaches negative infinity. So what would the function itself be getting closer and closer to? Well, judging from the graph, it's getting closer and closer to the value of 3. So that's the limit. Okay. Now, what about the limit of f of x as x approaches positive infinity? All right, so we will look on our graph and see what the function is approaching as x goes to positive infinity. And again, it's also approaching the value of 3. So it approaches the value of 3 at either extremes. That's the end behavior of it. All right, so these are the type of questions that you're going to be asked about the rational function that you are given. And so let's practice another one. We have another rational function here. First thing it's asking me for is the intercepts. And so again, if you want the x-intercept, you could plug 0 in for y and solve it. And if you want the y-intercept, you could plug 0 in for x and then solve it. Okay, but I say that it's probably faster to just graph it and let our Desmos calculator give it to us. And so that's what I'm going to do here. So I'm going to come in and I'm going to change the values as necessary here. So I'm going to make this a 3 on the top right here. And I'm going to come down below and I'm going to change this to x minus 2. And I'm going to come out here and I'm going to change this to a minus 2 on the end. And here's my new graph. Alright, so when I'm taking a look at this here now, I notice that it doesn't match the graph on the paper. Anybody see why? Well, it's because on here I forgot to put this negative in there. So that's always a good double check to make sure that you haven't made any sort of mistake. Compare it to what you've got on the paper and then make sure it's correct. So make sure you don't leave anything off, because that does make a difference, as you can see. Alright, so now the next thing I want to do is let my graph kind of give me the x and the y intercepts, and they're kind of close together here, so I'm going to zoom in a little bit to kind of give myself a little space. Alright, and so now I'll hit this again and I'll hit my 2 points again, and I can see that my x-intercept is at 1/2. You could write it as 0.5 if you want to, but the answer choices are probably going to be in fractions. And the y-intercept is going to be negative 1/2. Alright? Let's see now if we can find the domain of this thing. And so, judging from the graph, I would say that the only thing that's not a part of my domain here on this one would be 2, because of the vertical asymptote here. So again, we'll use set notation. So the domain is going to be all x such that x is an element of the real numbers and x is not equal to 2. Alright, so 2 is the only value that's excluded there. Otherwise, it's all the rest of the real numbers. So that's the only thing that doesn't count. Okay, so now we're asked to find some limits here on number 4. We're asked to find the limit as x approaches 2 from the left. So the limit of f of x as x approaches 2 from the left. That's what we want to try to figure out. Okay, so I want to find the limit of f of x as x approaches 2 from the left. Alright, so when x approaches 2 from the left, well, what does the function get closer and closer to? Well, it continues to rise the closer you get to 2, and so I would say that approaches positive infinity. Now, the next thing we're asked for is the limit of f of x as x approaches 2 from the right. Alright? Limit of f of x as x approaches 2 from the right. Well, when x approaches 2 from the right-hand side, then notice that the function itself is getting closer and closer to negative infinity. Alright, negative infinity. Alright, question number 5. Ask us to find the limit of f of x as x approaches negative infinity. Alright, as x approaches negative infinity, let's see what happens. So as x, as x approaches negative infinity, then the function value itself gets closer and closer to negative 2. Alright, it'll never quite reach it because that is a horizontal asymptote, but the further you go toward infinity, negative infinity, the closer and closer it gets to negative 2, so that's actually the limit. So remember the nature of the limit. Limit is not saying what it becomes equal to, it's saying what does it approach? What's the limit of the value? All right, so limit means that it's not necessarily equal to, but the limit is approaching that. So keep that in mind about the nature of what limits mean. The next thing is I want the limit of f of x as x approaches infinity. So as x approaches infinity, what does the function value get closer and closer to? Well, it also gets closer and closer to -2 from that other side. All right, so there you go. All right, so with that, that's pretty much everything that you need to make sure that you can go through and answer the questions that are on your quiz. And that is it for the 2 lessons for today. All right, we're done.